Hello students, welcome to my channel Engineers Academy. Kindly subscribe my channel for such more problem solutions. Now I am going to solve this particular problem from chapter 6 Hibbeler Statics. And this problem again it is said that determine the force in each member of this given truss and state if the members are in tension or compression, right? And P1 and P2 are given, right? Since this is P1 and P2. So again we will start this problem with that particular joint where we have at least two unknowns, right? So we can start solving this problem from this joint D, right? So if I write that we will consider joint D for equilibrium, right? So now if we consider this joint D for equilibrium, so we can draw the free body diagram for this joint D. Let me draw it. So we have these two forces, right? This is that joint D. Let me write here. This is that joint D. Here we have that P2 force, which is 8 kilonewton force, which is acting vertically downward, right? So this is 8 kilonewton force. And let's assume that this DE member force is acting away, right? So let's say that this is FDE, this is acting away, right? And let's assume that this FCD member force is acting towards this joint D, right? This is FCD. So if you people have three forces at a particular joint, so you people can assume, you people can predict the accurate direction. How? If we add these three forces by head to tail rule, so these three forces must always give us the zero resultant. They will always make a closed triangle if we have at least three forces, right? And if we have more than three forces, so again if we add all of those forces by head to tail rule, so they must always give us a closed polygon, right? Since the whole truss is in equilibrium, so if the truss is in equilibrium, so each joint is in equilibrium, and if each joint is in equilibrium, so the summation of all forces will be equal to 0. So the resultant will be equal to 0. So if the resultant is 0, so the number of forces, adding them by head to tail rule, they will always give us the 0 resultant, and they will always make a closed shape, right? So now if we look into these three forces, so this is FCD, and this is 8 kilonewton force, and then this is FDE, right? And if you people cannot predict the accurate direction, you people can assume the forces acting away from that particular joint. So you people must assume the tension forces always, right? So now let's say that these are the forces at that joint D. So now if I apply the summation of forces along y equals to 0, so we have to resolve these forces. So to resolve these forces, this is that FDE force, so we have to find this angle theta, right? Since this FDE is making angle theta with the horizontal, so if you want to find angle theta, so we can use this triangle, this CDE triangle. So from this CDE triangle, we can write that tan theta is equal to this CE, which is 2 divided by base. The perpendicular is 2 and the base is 1, right? So this is 1. So we can find theta by taking tan inverse. So this will be tan inverse 2, and this gives us angle equals to 63.44 degrees. So theta equals to 63.44 degrees. So now if we want to apply this equation, so then we have to resolve this FDE into its components. So it will have two components. It will have one component which will be acting in this direction. This one will be the cos component, and it will have one component which will be acting in this direction, that is in the positive y direction, right? If this is our positive x and y direction, if this is my positive x and y direction. So now if we apply this equation, so then as we can see that this is the sine component of FDE, so it is acting in the positive y direction. So I will write FDE sine of theta, which is 63.44 minus this 8 kilonewton. So this will be equal to 0, or we can say that this will be equal to 8. And if we divide both sides of the equation by sine of 63.44, so then FDE will be equal to this 8 divided by sine of 63.44 4 is 8.94 kilonewton, right? So this is 8.94 kilonewtons. And as we can see that this FDE is acting away from this joint D, so this means that this is the tension force. Similarly, if we apply the summation of forces along x equals to 0, so as we can see that this FCD is acting in the positive x direction, so I will write FCD minus the cos component of FDE. So FDE is known 8.94 cos of theta, and theta is 63.44. This is equal to 0. Or we can say that this FCD is equal to the cos component of that FDE. So if we solve this, then FCD equals to 4.00 kilonewton approximately, right? And as we can see that this FCD is acting towards this joint D, so this means that this is the compressive force, right? So now we know this FCD and this FDE. Now after this, if we consider joint C for equilibrium, right? So now if I draw the free body diagram of joint C, this is joint C. So here we have that joint C, and this is that FCD member force, and FCD member force is compressive, so it will be compressive here as well. It will be acting towards this joint C as well. This is FCD and its magnitude is 4.00 kilonewton. And let's say that this FBC member force is acting towards this joint C. This is our assumption, right? And let's say that this is also, this FCE is acting in the positive y direction, right? So this is FCE force, and this one is FBC, right? So again, if we apply the summation of forces along y equals to 0, so then only in the y direction this FCE force is acting, right? So this means that this FCE force is equal to 0. So this means that this CE member is 0 member, right? Since the force of this CE member is 0. By inspection, we can also say that if there is no external force in the opposite direction of a given member, so then that member will be a 0 member, right? So as we can see that this FBC, in the direction of FBC there is one another force, right? There are two collinear forces, right? But in the direction of CE there is no collinear force. So if this is the case, then that member will be a 0 member. So in this particular case, this FCE is a 0 member. So now if we apply the summation of forces along x equals to 0, so this FBC is acting in the positive x direction, so I will write FBC minus 4, and this will be equal to 0. So from this we can conclude that FBC is also equal to 4 kilonewton, and as we can see that this FBC is acting towards this joint C, so this means that this is also compressive force. If we solve joint E, right, joint, so now let me draw the free body diagram of this joint E, right? This is our joint E, right? So this is the FCE force. Let me write the forces, right? This one is FED or FDE, right? So we can write that this is FDE, and we know the magnitude of FDE, which is 8.94, and it is the tension force. So if it is the tension force, so it will be acting away from this joint E as well, right? So this is the tension force as well, and its magnitude is 8.94 kilonewton, right? And this is that FCE member force, and this is 0, so we will remove it. There is no need of this force, right? So now again, if we look into these three forces, so we can assume that this FEF member force is acting away. If I select the direction of these three forces like this, if this is acting away and if this is acting towards this joint E, so if we add these three forces by head to tail rule, so they will give us a closed triangle, right? So this is the accurate prediction of the direction if you people use that method, right? So we can write that this is FEF, and this one is this force, this is FBE. So now as we can see that this FDE member force is making that same theta here, right? This ED member is making that same theta here. So if this is the case, if here it is making theta, so it will be making that same theta here, right, and that theta is known, which is 63.44. So now if we apply the summation of forces along y equals to 0 at joint E, so for that we have to resolve these two forces. So if we resolve this FDE into its components, so it will have one component which will be acting in this direction, and it will have one component which will be acting vertically downward like this. And similarly, as we can see that this FBE member force is making some angle as well. So let's say that this angle is alpha. So now if we apply tan alpha to this triangle, right, this BCE triangle, so this CE is 2 and this BC is 2. So this means that this angle is 45 degrees, right? There is no need to find, right? So we can apply tan alpha. So tan alpha will be 2 divided by 2, and 2 divided by 2 gives us 1, and alpha tan inverse 1 will give us 45 degrees, right? So this means that this angle is 45 degrees. So this means that this FBE is making 45 degrees angle here, right? So if this angle is 45 degrees, so we can resolve this FBE into its components. So it will have one component which will be acting in this direction, and it will have one component which will be acting in this direction, right? So now if we apply the summation of forces along y equals to 0, so this one is the sine component, right, and this one is the sine component of FBE as well, right? So we can write that this component is acting in the positive y direction, so I will write FBE sine of 45, this is acting in the positive direction, minus this is the sine component of FDE, and FDE is 8.94. So I will write 8.94 sine of theta, which is 63.44. This will be equal to 0, or we can say that this will be equal to this thing, and FBE will be equal to, if we divide both sides by sine of 45, so that will give us the FBE member force. So this gives us 11 point FBE member force is equal to 11.31 kilonewton, and as we can see that this FBE is acting towards this joint E, so this means that this is the compressive force. Now if we apply the summation of forces along x equals to 0 at joint E, so this cos component of FDE is acting in the positive x direction, right, and this FEF is acting in the negative x direction. So first I will write this unknown, right, so I will write minus FEF, this is acting in the positive x direction, so this is the cos component of FDE, so I will write plus FDE is 8.94 cos of theta 63.44. This component is also acting in the positive x direction, so this is the FBE component, so FBE is 11.31 cos of 45 degrees, so this is equal to 0, or we can say that if we bring this FEF to the other side of equation, so FEF is equal to the summation of both of these. So this gives us FEF equals to 12 kilonewton, right, and as we can see that this FEF is acting away from this joint E, so this means that this is the tension force. After this we will consider joint B. So now at joint B we know this this force, right, this is FBE force, and FBE force is compressive force, so it will be acting towards this joint B. So let me write here, right, we know this FBC force, so this FBC force is compressive force, so it is also acting towards this joint B, right, and we will assume so the direction of this FBF member force. So let's say that it is acting away, and let's say that this FAB is acting away from this joint B, and here we have this P1 as external force, right. So let me isolate this free body diagram. This is the joint B forces, right, and here we have that P1 force which is acting vertically downward. So this P1 force is 10 kilonewton, this is given, right, so I will write this is 10 kilonewton. So this is FAB right? This one is FBF, this one is FBE, and its magnitude is known, right? So FBE is 11.31, so I will write 11.31 kilonewton. This one is FBC, and FBC magnitude is 4 kilonewton, right? So we will write FBC, this is 4 kilonewton, and both of these are unknown, right? So again, if we apply the summation of forces along y equals to 0, so we have to resolve this FBE force into its components. So again, it will have two components. It will have one component should be acting in this direction, and it will have one component should be acting in this direction, right? So this FAB is acting in the negative x direction, so I will write we are applying the summation of forces along y, so this FBF is acting in the positive y direction, so I will write FBF, and this 10 kilonewton is acting in the negative x direction, so I will, in the negative y direction, so I will write minus 10, and this is acting in the negative y direction, and it is the component, the sine component of FBE, so I will write minus 11.31 sine of theta, sine of alpha, so alpha is 45, right? So we will write that this is 45 degree, and this is equal to 0. So FBF will be equal to, if we bring these two terms to the other side of the equation, so their sign will become positive, right? So we can write that FBF equals to 18 kilonewton, right? And since this FBF is acting away from this joint B, so this means that this is the tension force. And similarly, if we apply the summation of forces along x equals to 0, so as we can see that this FAB is acting in the negative x direction, so I will write minus FAB. This FBC is acting in the negative x direction, so I will write minus 4, and this FBE cos of alpha is acting in the negative x direction, so I will write minus, and this is 11.31 cos of alpha, which is 45 degree, and this is equal to 0. So from, if we bring this FAB to the other side of equation, so this will become positive, so this will be FAB. So FAB equals to minus 12 kilonewton. So this minus sign means that the FAB force is compressive force, right? Since we have assumed that it is the tension force, but the negative sign tells us that the assumed direction is not accurate, so it is acting towards this joint B. So we can say that FAB force is equal to 12 kilonewton, and it is compressive force. And the last joint that we will consider is this joint F, right? So we will consider joint F, right? So now at this joint F, we know this FEF member force, right? So FEF member force is 12 kilonewton, right? We have determined this while solving joint E, right? So FEF is 12 kilonewton, and it is the tension force, so it will be acting away, right? Let me write that this is that FEF, right? This FBF member force is also tension force, and its magnitude is 18 kilonewton, right? So this is tension, and this is 18. This FEF is 12 kilonewton, so I will write this as 12 kilonewton, right? And we will assume that this FGF member force is the tension force. Let's say this is FGF, and let's assume that this FAF member force is also compressive force, right? So we have these 4 forces, 2 of which are unknown, right? So this is FAF. So now if we look into these two triangles, this FBF triangle and this CDE triangle, both triangles are similar triangles. So if this angle is theta, then this angle is also theta, right? So this means that this FAF member force is making theta angle here, right? So if this is that theta, So this angle is also theta, right? So now if we apply the summation of forces along y equals to 0 at joint F, summation of forces along y equals to 0. So we have to resolve this FAF force, right? So it will have one component which will be acting in this direction. This one will be the cos component, and it will have one component which will be acting in this direction. It will be the sine component. So now as we can see that this is acting in the positive y direction, so I will write FAF sine of theta, and theta is 63.44, and this 18 kilonewton force is acting in the negative y direction, so I will write it like this. So from this we get FAF equals to 18 divided by sine of 63.44. So this gives us FAF member force equals to 20.12 kilonewton. And since this FAF member force is acting towards this joint F, so this means that this is the compressive force. And similarly, if we apply the summation of forces along x equals to 0, so now as we can see that this FGF is acting in the negative x direction, so I will write minus FGF, and this is acting in the positive x direction, so I will write plus 12, and this cos component is also acting in the positive x direction, so I will write plus, and FAF, this is the cos component of FAF, so FAF is 20.12, so I will write 20.12 cos of theta, and theta is 63.44, and this is equal to 0. So if we bring this FGF to the other side of equation, so we will have this equation. So this gives us FGF equals to 21 kilonewton, and as we can see that this FGF is acting away from this joint F, so this means that this is the tension force. So we have determined the forces in all the members of this given truss. I hope you people would have understood this particular problem. Like this video if you people want me to solve such more problems. Also subscribe my channel if you haven't subscribed it yet.